Type of states. Okay, so there appears to be a certain number of state types. There really aren't that many, by the way. Generally speaking, we have basically something we refer to as creation or initial pseudo-state, like we're coming out of, some sort of pseudo-state and arriving at the first normal state. So it's like, basically just a big black dot like this, and the transition goes to a first state, and we say, in use, right? Just as an example here, bubble that says in use, right? And when we're done, we said that the final state, the exit state, can be, depicted like this. We just say that once we exit to the state, this is final. And final really means that it's no longer in use. Maybe the object got destroyed, so it really doesn't exist, or becomes dormant until it's pulled out of out of shelf, out of some kind of storage for the next type of use. The only thing about this, there could be potentially multiple normal states, but usually the initial state, initial entry into this typically is just one. However, because we can be in use and we can be in other states over here, right? We can transition to various states in the state diagram. Just to let you know that the final states, there could be multiples. There could be another final state right here, right? So you could exit the states from different places. It's possible, okay? So transition, and again, there could be final state 1, which is like destroyed, and final state 2, which is like dormant, right? So that's why there could be, multiple types of final state where the object is no longer in this operation for whatever reason. So just be aware of it, that it's not that uncommon to have multiple exit states or final states for the UML, right? So I would say that in our example of the elevator thing, that it would be maybe natural for us to arrive, normal operation, normal type of operation. So the initial state may be over here, right? So we enter into the standing state, which is like a normal type of state, and just indicate that essentially the operations from the creation of object, this is maybe how we want to create every elevator. When you want to create the object and initialize it into the standing state and execute all the actions associated with the standing state. Do we have any exit state here? I don't think so. I mean, we can really destroy an elevator in any state if we want to get rid of it in after simulation is complete, or we could just shelve it and see if we want to reuse it again. So here I wouldn't really need to specify an exit state in any of these 6 states that we tried to analyze already. All right, but if I wanted to, I could just say, if I wanted to specify something like this, right, and just to say that this is my exit state, that would require me, okay, if that was part of my diagram, that would mean that I cannot destroy this object or abandon this object without first going to the maintenance state, and then somehow from the maintenance state I can go and say, exit, and that would be the final state right here, right? But again, this wouldn't be something I would do with an elevator. This is completely unnecessary. It's not critical to leave it in any state, and basically, if the user wants to stop the simulation, after all, in our problem domain, we run the simulation. So if we want to stop the simulation, we can stop the simulation in any state and abandon the simulation, so this is not critical. But if you're really operating the equipment, of course you probably want to consider all conditions to be driving the final state, if we want to have a final state at all. All right, so state examples. This is with a switch. Basically, a typical switch has two states, on and off, and we can attempt to go up and down, and we want to we can basically we can have these two types of transitions, and you can, with respect to physical equipment, you can say that the event that happens here is connect, and disconnect is the other type of event over here that puts it out of service, right? So that's just a very simple demonstration on the initial and final states and the two normal states. So we already said that we can have conditions, and I try to use conditions in my example over here using the square brackets, right? So essentially in our system, different conditions drive those things, but the formal formal way of doing this is, you can say that I want to, for instance, this is an example of a container, right? And we have the container, which can be in three states. It can be empty, it can be full, or it can be partially filled. So perhaps it's an array which is capable of holding a limited number of elements, right? So we say that if we add the element, and conditions are specified in square brackets, and the capacity, which is the property. Remember, the entire state diagram refers to the data attributes of the same object. So therefore, it's easy in the state diagram to just refer to specific attributes, such as this capacity, and say if capacity is 1, if the capacity is 1 and we're just adding the element, we're already full. If the capacity is greater than 1, adding the element, the same action, drives you to just partially filled. So just an example of a possibility that the same event, add element, or the same incidence under two different conditions transitions you to two different states, right? So that's just something that you can add to your state diagrams. But I think that at the same time, sometimes it's easier to describe it, to provide description, additional description to your state diagram, and just write it, write it as a normal description of the functionality, and not necessarily, overpopulate your diagram with these indicators. So it depends, again, on your problem domain and how much you want that to, how much of it you want to indicate on the diagram. Actions in state. So we said over here, we said that actions can be linked to state transition, state entries, and state leave. So inside the state here, the entry, if you want to use formal UML, you can say that in empty, upon entry, you can set the count of my element count, if we're still staying on the example for the collection class, we can say that the count is set to 0, right? So upon any entry into an empty state for this collection of some elements. We want to set the count of elements equals 0, something like that, right? So again, is this really important to indicate on the state diagram? Again, it depends on your problem domain. Sometimes it'd be just overcrowding it, because it's sometimes the most important part is really the name of the state, and these are the details that you could provide. So UML allows this to happen, so that's why. Actions in transition, you can use the forward slash and some sort of statement that represents an action. I wouldn't advise doing this because, again, I think that it's just overcrowding the diagram and makes it harder to interpret because, again, there could be, this could be important to you when you're writing the implementation. For the most part, you just want a quick overview of states available, state transitions that are available, and with that respect, you just want to see the states and transitions and not these little details. So that's just that is not something I would advise on a regular basis to do. So upon entry and exit, you can continue to use your state diagrams and specify actions in forms of messages. So you know that we said that objects can message each other, and so you can specify that I want to, like, so here's a full state for my container, and if I'm entering the full state, I want to use my log object and say that stack is being filled or stack full, and specify the time when the event has occurred, and then upon exit we want to again call the log object and say we want to log that the space is now available, and again provide the time. Is this something you want to, is this something typical you want to do in your state diagram? I really don't think so. I would in fact not advise doing this. This would be an overpopulating the state diagram. Again, the most important parts are normally the state IDs, the names of states, description of these states, description of the events, and then a combination of states and events describing the transitions. And typically, just like with use case diagrams, it all comes down to actually describing what it is, right? So don't overuse this, but UML does provide this type of capacity to specify messages, and so here's adding the element with condition, sending message to a log, specifying some sort of parameter. So again, this is in transition. When the transition occurs, you again can use the name of your action, the condition which has to be true so that this action actually causes this transition, and then you can also add a message to another object and even more like parameters that you want to send over with that type of message. So this is like, this is long, and typically could be confusing a lot of audience to look at it, because once you have the presence of cryptic, parentheses, square brackets, some sort of caret here or upper symbol representing the name of the object, and condition with all of its double equal signs and other types of logic that you can use in your conditions, it quickly becomes too complicated to comprehend for many audiences, right? So messages and transitions, again, you can also indicate perhaps exceptions, right? So you can essentially indicate that instead of calling a specific object to pass some information, instead you can throw an exception and specify the type of exception that you're using. Again, this is greatly depends on your on your domain. But the topic is interesting because what happens here is that, yes, you can have exceptions, right? Every time you attempt a transition from one state to another state, right? What if you have a fire alarm at the time of transition? Or what if you have some part of the equipment failing? So during your transition something happens, something unusual. How do you react to this? You can throw an exception. So exceptions can be indicated. I would actually use a different color over here, and I can say that you can still use the square brackets to say this is my condition, right? And you can basically say that you throw a specific exception, right? Exception, and provide the parameters for that exception. Is this enough to just indicate something brief like this? Again, depends. If everybody on your development team completely understands what it is, it may be fine today, but in a year from now, someone who has to maintain this, this really deserves some kind of additional, comment over here that describes what it is, or a separate document that would, keep the diagram readable and usable. Right, so normal type of descriptions are very important. Okay, so anyway, exception in case of a state diagram is a different kind of a message, right? So there's definitely a caller who may be causing this transition to happen, and you may signal that all of a sudden there's an exception, so things really don't go too well with that. Next stage here. So I mean, if you have any questions, it's the right time to ask. Otherwise, we're going to also discuss yet another type of the diagram here, which is an activity diagram, which is yet another procedural diagram. But that's our coverage today for the activity diagrams.